Hello everyone, today we're going to be talking about Physics 252 Week 2 Video Explainer problem number 4. In this problem, we are asked to find the angular velocity of a turntable after two masses fall on it. So I've kind of interpreted this turntable as actually being a turntable, and I have a record player here of mass m, as we can see in the problem, and of radius r. So these masses that fall off, so this is our initial state I right here, this is our final state F right here. So these masses, they fall on at 1/2 of the radius. So there's two of them, they're kind of sitting on the disk like this at r divided by 2 away. So some things that might be helpful before we get into this problem are the equation for the angular momentum, the moment of inertia of a solid disk, and the moment of inertia or how we get final moment of inertia from the sum of all the initial parts. All right, so getting into the problem here, what we can do is because the angular momentum is conserved, we can say that the initial state equals the final state, right? So from here, we can say, kind of replace the angular momentum with the moment of inertia times the angular velocity. And we can kind of do this for the initial and final state here. And then we can just rearrange and solve for the final angular velocity, which is what we're looking for in the problem here. So this is close, but we can expand on this more. So in the next part of the problem, we're going to be doing this sum right here. So we're going to take all the initial states and we're going to add them up in order to get the final state. So here we have our very first initial state, which is just the moment of inertia of the disk. And then we also have the moment of inertia of the small masses here in the radius away, as you can see in the problem here, and that is squared. So we can simplify this down to get that our final moment of inertia here. So now we can just kind of plug and chug, go ahead and plug into our equation that we derived in the first part here, or not derived, but solved for algebraically. And we can just plug in all of our constants, or not constants, but values here for each of these. Of course, we don't have the initial angular velocity, but we can plug in our initial moment of inertia and our final moment of inertia, and we are left with this equation right here. And this equation will give us the final angular velocity after these two masses fall on our record player. So thank you very much for watching, and I hope you found this video helpful.